Hi guys, BuildZoid here, and today we're going to be taking a look at a B450 motherboard, the first one, and an MATX one at that. So this is the B450M Mortar Titanium from MSI, and of course I bought this board, so big thanks to the patrons for, funding the purchase of this thing. And let's get right into it. And I bought this board specifically because I think this is one of the, this board has a very good chance, and also its derivatives, because there's basically an ATX version of this thing, with like the same VRM and then the same heatsink. And there's also the regular Mortar, which is this board, except not silver. Silver white. This is not actually, like, the board's not actually white. It's like this silver color, which is why they call it titanium. So yeah, and basically this board, at least hardware wise, VRM wise, looked really, really promising. So that's why I picked it up, because it's like this could be, like, at least I'll know of one B450 motherboard that I know for sure doesn't suck, assuming this doesn't suck. I don't know how the BIOS is yet. I've not turned it on, but I have taken it apart, and so here goes the VRM breakdown. But well, VRMs and the PCB breakdown stuff. But before we get to that, let's take a look at the heatsink that this comes with, because this is a proper heatsink. Like, I'm super happy with what MSI has done with this heatsink, because we have fins, as you can clearly see, like the fins freaking everywhere. There's these little ridgy things that I wouldn't really call that fins, but it does add surface area, so that counts. Then on the back, we have yet more fins, as well as this giant fin thing. It's like, look, somebody designed an actual heatsink instead of a modern piece of art. I mean, it has a lot in common with a modern piece of art, except this has a lot more surface area than a lot of the heatsinks you find even on like $150 X470 motherboards. And this heatsink right here is basically like, the thing is like, there's a lot of motherboards on X470 where the heatsink doesn't come even close to this, right? And in my opinion, that is inexcusable, because MSI is able to put this heatsink onto a motherboard that costs less than $100, right? Like, if you don't get the titanium version, this heatsink, like the board, they make boards with this heatsink that are under $100. And because of that, is basically a case of, there's no excuse for having a $100+ motherboard with a craptacular heatsink. Though MSI is kind of guilty of that as well, because like the X470 Gaming Plus from MSI actually has a worse, at least I think it's worse heatsink than this thing. So, but it's just like that. This is a real heatsink, and I hope that MSI basically going forward, they just keep recycling this heatsink as much as possible, because this has a lot of surface area. It's reasonably heavy. It, like, the only thing that's a concern is getting the hole spacing, but for any like generic sort of 4-phase, even like weaker 8-phase VRM or 6-phase, like, you could fit a lot of different VRM implementations under this heatsink. So I hope MSI just keeps using this, because this is a really, really nice heatsink. It has a lot of surface area. It should do a great job of cooling the board. So this is by far, like, actually, honestly, out of all the boards I've looked at, except for maybe the MSI X470 Gaming Pro Carbon board, I think this is actually, the Carbon might the heatsink on the Carbon might be similar in terms of surface area to this one here. It's definitely heavier though, but in terms of actual heat dissipation capabilities, I think they might be about evenly matched. So honestly, this is one of the best heatsinks I've seen on like any, X470 or B450 board, except the, like, obviously up at the very top we have Gigabyte with the with the Gaming 7 board, and that has like the proper fin stacks and the heat pipes. The thing is, Gigabyte has that very, very good heatsink on like one board, right? Like, they have it on the Gaming 7, and then all the other boards Gigabyte makes have your usual art blocks, and as you go down the product stack, they get steadily less and less functional. So yeah, this is like the gold standard for an affordable heatsink as far as I'm concerned, and every other motherboard vendor should just copy this thing. They should actually, hell, they should buy these heatsinks off of MSI and use them on their own boards, because this is what I want to see. Like, this has actual surface area, not the modern art pieces that everybody else produces. Because there's like say the X470 Prime Pro from Asus, right? That has a perfectly good VRM with a god-awful heatsink. So, yeah, and that's a $150 motherboard. And it's just like, I don't know why you couldn't just do what MSI did. Honestly, that VRM probably has the same hole spacing as this board does. I might check that. And if it does, then I might even... Actually, no. It doesn't. But, this heatsink would cover the VRM that's on there, if the hole spacing lined up. Anyway, let's get on to the VRM, where MSI impresses yet again, which is really surprising, because on B450... MSI was was one of the MSI was terrible on B350, and then it looks like they realized that, hey, AM4 is actually going somewhere, it's here to stay, and it's pretty popular, and now all of their boards are way, way, way better than they used to be. So let's start off with the most important part, the Vcore VRM. And for the Vcore, we're looking at it's a 4-phase. And this is actually a very, very similar 4-phase to what you would find on like the X470 Gaming Plus, the X470 Gaming Pro, not the Carbon. The Carbon Gaming Pro board has a 5-phase, not a 4. And yeah, this is a really, really solid, this is a solid 4-phase. There's a slight downgrade in the Mosfets. Instead of using the on semiconductors with like a 2.5 milliohm RDS on low side, this is actually going for it also drops the extra inductor. But honestly, that might slightly change the thermal capacity of the VRM, but with that massive heatsink, I think that's honestly not going to be a noticeable difference thermally, and this might end up... actually, I would not be surprised if this VRM outperforms the the X470 Gaming Plus VRM on thermals, just because this has such... that heatsink is so much better on this board than on the X470 Gaming Plus. Which basically means if you're going to be buying like a budget AM4 motherboard, you might as well just buy a B450 motherboard with the heatsink that this comes with from MSI. If you're going to be doing like manual overclocking on like a 2700, because yeah, the VRM on this is actually it's a slight downgrade, but the heatsink is a huge improvement, I think. So it should work out better in the end. So then, 4-phase, and you get your 4 Mosfets per phase, so you have 2 high sides, and then you have 2 low sides. And for the low side, this is where both of the Mosfets are slight downgrades over the X470 boards, but the heatsink, I think, as I said, heatsink should make up for that. So on the low side, you're going to be looking at an SM4, am I writing that? Yeah, 4503 from Sino Power. So, and that's a 3 milliohm RDS on MOSFET. So compared to the X470 Gaming Plus, which uses a 2.5 milliohm RDS on MOSFET. So you get slightly worse low side MOSFET resistance, and you get the same kind of issue on the high side. So overall, the VRM efficiency goes down a little bit. It's not a huge decrease, but it definitely is slightly worse than on the Gaming Plus. And for the high side, you have the 4337 from Sino Power, and the voltage controller is MSI's favorite RT8894, and they use this thing just absolutely everywhere. This is used all the way up to the X470 Gaming Pro board. So again, the non-carbon. The carbon goes to the IR35201, but up to the carbon, Gaming Plus, Gaming Pro, all use this voltage controller. Slightly better MOSFETs on the X470 boards, better heatsink on this one. And the interesting thing is actually these MOSFETs are better than what you find on Gigabyte's X470 boards, significantly so. They're better than what you find on ASRock's X470 boards up until the Tai Chi. Basically, these are probably of the cheaper motherboards, these are some of the best MOSFETs you can get. 3 milliohms RDS on. Most other brands like Gigabyte and ASRock are hovering around the 4 million RDS on range, and I think ASRock might even be at 5.5 for some variants of their boards. So, MSI just really, really impressing me, because these are decent MOSFETs. I know, how hard could it be to make a VRM that doesn't run super hot? You get decent MOSFETs, and then you get a decent heatsink. Magic! Anyway, so... yeah, really solid 4-phase, and the end result of the solid MOSFETs is that this does still produce a pretty, it's still a 4-phase, so it does produce a not insignificant amount of heat. But for 1.42 volts and the voltage ratings, I'm keeping the voltages all the way from the first generation Ryzens. For the second generation Ryzens, you shouldn't be running this much Vcore across all cores because the 12 nano... Wait, is it 12 nanometer? Yeah, it's 12 nanometer from Glowflow has much more leakage than their 14 nanometer process. So for any given voltage, you're going to be pulling more power. So yeah, 1.42 volts is actually not safe for the second generation of Ryzen, whereas for the first gen, it would have been safe because those were on the 14 nanometer process. 12 nanometer process, you would want to stop around 1.38 because that negates most of the, like at 1.38, a second gen will pull roughly as much power as a first gen on 1.42. Actually, still a bit more just because they clock higher, but it won't be, like at 1.42, a second gen is like really scary hot. And that's really like the current pull is what causes all the degradation. So the voltages here are a holdover from the first gen boards because it makes them easy to compare against. They're not actually something I would run into a second gen CPU. Well, 1.42 volts, 75 amps, so that would be like a 6-core CPU. You'd be looking at about 9.5 watts of heat, which that should be no problem for the heatsink on this to handle. 1.42 volts, 100 amps, and this is, of course, 10 volts gate to source voltage, which I assume this board's just driving with 12 volt, straight 12 volts, because there's no dedicated buck converter anywhere on this board to generate 10 volts. They're just going to run it off of 12, which gives you the same RDS on performance for the Mosfets. So 10 volts gate to source and 300 kilohertz switching frequency, which incidentally, this doesn't work for this board because this voltage controller, it's that's a 4+2 phase. And the thing that's special about the RT8894 is that it actually has variable frequency. So at idle, it runs at 300 kilohertz. Once you ramp up to full load, it goes all the way up to 450 kilohertz. And for that reason, and so basically I'm rating 300 kilohertz for parity because that's how I rated the Gaming Plus, so you can compare against that board how much of a downgrade it was. But both the Gaming Plus and this will actually go all the way up to 450 kilohertz switching frequency. And so for this board, what I'm adding is that at the highest current rating, I'm going to add a 450 kilohertz heat output figure for the VRM. So 1.42 volts, 100 amps, you're going to be looking at about 14.5 watts of heat. Which that's already rounded up, and then I rounded it up again, so it's just like, no. Which is, again, the heatsink should have no problem dealing with that. And 1.42 volts, 125 amps, you're going to be looking at 20 watts of heat for 300 kilohertz, but at a 450 kilohertz, which is where the board will actually top out, you're going to be looking at about 24.5 watts of heat. So yeah, slight downgrade compared to the Gaming Plus because at 300 kilohertz, 1.42 volts, 125A, you're going to be looking at about 18 watts on the Gaming Plus, but whereas here it's 20. So you can see that there's a small increase in heat output. And that heat output increase also will translate up to the, the 450 kilohertz figure because the Gaming Plus at 450 is like 22 watts. So, the difference maintains across the frequency range. But the end result is this is still really respectable, like in terms of heat output for such a cheap motherboard. And with the heatsink that this has, as I said, I expect this to do absolutely great in VRM thermal testing because this has so much surface area compared to a lot of its competition that it should have no problem handling the VRM heat output. So yeah, this, assuming the BIOS is good, this should be a really, as long as MSI hasn't screwed up the BIOS, this should be a great B450M ATX motherboard for CPUs, and all of the other boards because MSI recycles this VRM across a bunch of other boards as well. Of course they do, otherwise they wouldn't do this. So the other boards that use this VRM are also a really, really solid choice, even for an 8-core CPU if you're overclocking, especially if you get like a 2700, which is locked. And, well, no, not locked. Shouldn't, as far as I know, it shouldn't have access to Precision Boost Overdrive. I've heard conflicting reports about how true that is from people who actually have those chips. I'm not going to go buy one because, I might buy one sometime down the line, but not anytime soon. Yeah, if you're not going to be using Precision Boost Overdrive, then like this VRM is really, really solid. And hey, if MSI manages to fix their Precision Boost Overdrive implementation, then actually this would still be really, really solid. And arguably, I wouldn't run Precision Boost Overdrive on a lot of the competition's board, because even if they have a better implementation, those boards might overheat. Just running like PB, like if you max out PBO and give yourself a minus 100 millivolt offset, a lot of the other boards might still overheat because their VRMs are garbage and their heat sinks more so. So yeah, MSI has like lots of potential here with the hardware that MSI has here. If they have a good BIOS implementation, this could be a really, really solid board. Now then, what if you want to overclock an APU? Well, if you want to overclock an APU, I actually have current draw figures now because I've been messing around with APU overclocking a lot recently. And this VRM up here, on the other hand, like as much as I like the 4-phase for the Vcore, this is like... that's the SoC VRM, and this has problems. So the reason why it's laid out so weird, where you have one phase here and the other phase here, so it splits down the middle, so it's a 2-phase. That's where you get the +2. The reason why they're doing that is to maximize the surface area that the VRM has to dissipate heat, because basically all of your heat is going to be generated in these Mosfets, and then it's going to soak into the board, something like that. Or at least in theory, it should behave something like that. Depends on how the internal power planes are laid out, but there should be one giant ground plane somewhere in the board. So it would soak into that. And so basically, they're trying to sink as much of the heat from the VRM into the board itself, and that's why they have the Mosfets, they have the Mosfets as far apart as possible. The thing is, this is still, like, if you're really going to be pushing an APU, which you don't need a lot of voltage to push an APU. In my testing, the 2400G, right, with settings of 1.4 volts Vcore, because it's a first-gen Ryzen CPU, even though it has the 2000 series name, 1.4 volts Vcore with 1.15 volts SoC. If I ran that chip in if I loaded up that chip to like full load, I was getting like 120 watts of CPU power consumption. And the CPU portion on one of these chips really doesn't pull much more than 60 watts, which means you're pushing something like 60 watts on the iGPU. And and that's a pretty low voltage, so you're looking at a lot of current pull. And so for that reason, I've actually changed how I rate the SoC VRMs for the APUs. And yeah, the end result is this could this will be interesting to see how hot this gets with an APU, and I will be testing that specifically because this doesn't have a heatsink, and this, who knows? There's also a chance that MSI's APU overclocking on this board is just as bad as it is on the X470 boards I've tested from them, in which case you don't have to worry about the SoC VRM because you can't really overclock the APU much anyway. But if they do have a working APU overclocking implementation, the thing is, the competition's VRMs don't look much better than this anyway, so who knows? This might actually work out for MSI just fine. In comparison, not in a vacuum. This is not great. But anyway, so for Mosfets, you're looking at the same thing as on the Vcore VRM, so the same low sides, same high sides. So that chip and this chip again. And the end result of those MOSFET selections is that for 1.15 volts, 10 volts gate to source, 300 kilohertz, you're going to be looking at the following: 1.15 volts at 20 amps output, which would be like that would be like the system on a chip portion of a CPU Ryzen. So like a 2700X or a 1800X, that would be roughly what you'd be looking at on those. It's going to produce about 2 watts of heat, which it should have no problem dissipating that amount of heat. Then if you go up to 1.15 volts, 30 amps, which would still, under some scenarios, a CPU might hit that. This is more APU range at that point. You'd be looking at about 3.5 watts, which still not concerning. 1.15 volts, 40 amps. This is well into the APU power consumption range. You're going to be looking at about 5 watts of heat, which this still shouldn't be a problem. 1.2 volts, 50 amps, you'd be looking at about 7 watts of heat. And at this point, it's like, okay, this might start causing issues. And I've run out of space, so we're just going to continue over here. 1.2 volts, 60 amps, which under certain workloads, the APUs might hit that. At that point, you're going to be looking at about 9.5 watts of heat, and that I'm going to say that would be a problem. So yeah, I will definitely be testing APU overclocking with this board as well as VRM thermals when APU overclocking, because this has no heatsink, and that is concerning. Even with the like thermally optimized layout that they're going for, the lack of a heatsink could be quite a problem. So yeah, I'll be interested to see how that actually works out in practice. Now then, memory VRM, massive overkill here, because guess what? They're still using the same Mosfets, which is a good thing. I mean, if you're buying one part a lot, you might as well just use it everywhere. So you're, again, for the low side, you're on the SM4503s and SM4337s. One inductor, so this is a dead giveaway that this is a single phase, which is fine. Most of the motherboards, like up until high-end X470, most of the motherboards use a single phase memory VRM. It's just some of the manufacturers have an extra inductor there for aesthetic purposes. It doesn't actually electrically do anything. And this is, yeah, like this is going to have no problem. I mean, this is half an SoC VRM, and DDR4 memory sticks really don't pull that much power, so you don't need to worry about that. Next to that, we have some debug LEDs, which are a very welcome sight because a lot of other motherboards don't even bother to put postcodes. So these are definitely handy when you're overclocking if you need to troubleshoot something. You have debug LEDs. They indicate basically boot media errors. So like if you don't have an SSD connected or something like that, one will light up to indicate that there's a problem with that. There's a GPU error. If you have no display output, that'll probably light up. DRAM error and CPU error. So yeah, depending on what you run into issues with, one of them will light up. Not as, it's not as detailed as having a postcode. It's a lot better than having nothing. So that's very welcome on the motherboard, in my opinion. And up here you have a BIOS clear switch where it should be, because this way you can access it without opening the entire computer. Because MSI does have a board where they have a BIOS clear somewhere in the I/O section, which is like, I mean, it's nice that you have a switch, for clearing the BIOS. The only issue is I don't think most people with that board are going to run it on an open air test bench. So it's going to suck when they actually need to press that button. But here it is where it should be, on the rear I/O, which I have heard a few people complain about hitting that when trying to plug in USB stuff, but it's like, I mean, don't hit it, I guess. Look where you're sticking your USB devices. So yeah, that's the B450M Mortar Titanium. You get a solid 4-phase with a very impressive heatsink, and then a 2-phase that, while solid, might not make it for, heavy APU overclocking. Who knows if that'll even work, because, as I said, on the X470 boards, the APU support has been less than stellar last I checked. But yeah, overall, I really, really like this board. You get your debug LEDs, you get a single-phase memory VRM. Like, this is what I like to, like, this is my idea of a budget motherboard. There's not really much more I would want on here. You have solid MOSFETs, you have a solid 4-phase. That voltage controller supports LLC settings, so I assume this board should have LLC settings in the BIOS as well, because the other boards that use this controller have it. Well, the higher end boards that have this controller do have LLC, so I don't see a reason why this wouldn't. It's not like this VRM is so bad that, not having load line calibration settings would protect it. Because it is, for some boards, not having load line calibration is a good way to prevent the VRM from overheat. Well, it's still going to overheat, it's just going to overheat slower instead of really quickly. So, yeah, that's... Yeah, this is a solid board. It'll be interesting to see how the BIOS works out. And it does, it does only have one BIOS chip right there, but, at this, there's so few dual BIOS boards. Well, except Gigabyte. Gigabyte has dual BIOS everywhere, but Gigabyte has other problems to fix. So, yeah, and honestly, I mean, I still think dual BIOS would be really handy, but it's not the worst thing ever. Like, yeah. This is a really, really solid board for like the price. And then the best part is that this is actually like the more expensive version because of the titanium edition. You can get the regular black B450M mortar, and it's this board just in black. And then MSI has a bunch of, and I assume they have a bunch of other boards that use the same VRM. Might be a bit hard to track them down, but those should all be solid as well. Especially if they still stick to this heatsink. Like, this heatsink is awesome. So yeah, that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comments section below. And if you would like to support what I do here with actually hardcore overclocking, like buying motherboards and then testing them, and also extreme overclocking stuff also, then I have a PayPal, Patreon, t-shirts. You can find a link to all of that down in the description below. Those all help out immensely. Because I like to buy, it's like when I buy the boards, it's not like I'm risking losing sampling privileges when I complain about something being terrible. So yeah, that's it for the video, and goodbye. Now I need to go find that stop button. Where is it? There it is.